Hey everybody, we're going to move into this next video on gravity. Remember that you really need earbuds for this unit. It is so important because we can't show you everything without having some sort of video. So make sure you get some. It's important. It's part of your supplies as well. But moving into gravity. These are notes, and you'll want to open your digital notebook. I'll move over my key tab. And you can see here that the three fill-ins for gravity are just on the side here on page 20. So you'll want to go to slide 20. You should at this point have everything filled in to the side here. And I can zoom in. So kind of to show you at 100%. I have all this filled in. And if you need to pause and fill it in, please pause and fill it in. So you kind of look here, everything's filled in, filled in, filled in, filled in, filled in, filled in. I'm also going to add for the sun here, and you can hear my little girl whining, so I apologize about that. But sun is a star. Many kids in the past have thought maybe it's a planet, but it's not a planet, it is a star, so make sure you know that. But everything is filled in here. If you need to pause and fill anything in, please do that. You need to watch these videos. It's important. Remember when we have a test coming up? It's all going to be from your notes. So if you don't have your notes, and I mean your own notes, we're not sharing, okay? So make sure you know that. So if I scroll back up here, make sure you pause and go write these in if you want. They're here, all right? So pause and write them in. But going back to the notes, gravity, well, we gotta know what it is first. I'm going to read from here. I'm going to show you a couple videos, and yeah. It's a natural force of attraction exerted by a celestial body, like a planet, on objects that are on or near its surface. So, it's a force. I mean, you guys learned about forces in the force of motion unit. It's like an attraction between two objects. So that's that, all right? And I'll show you a video with that. But you have to remember, when we talk about gravity, we're talking about forces as well, okay? And you'll want to fill that in this part. So moving on to the second slide will be the second slide there. Gravity. How does the mass of an object affect gravity? Well, the greater the mass of an object, the more gravitational force is exerted on other objects around it. So the greater the mass of an object, well, remember, mass doesn't change. For example, when we were in the density unit, you guys learned about the difference between mass and weight. Well, when we talk about mass, mass does not change. So if I was on planet Earth, and wow, she's really screaming. She's having a fit. And I'm upstairs right now, so you might hear that. But anyways, when I talk about mass, I'm talking about the fact that no matter where I am, whether I am on planet Earth or the moon or Jupiter, my mass does not change. It is how much matter I am made out of, and that is not going to change, okay? Now, weight does change. The reason weight does change is because gravity does change on the different planets. Now, for a misconception, there is a thought that many kids think, and adults even, that there's no gravity in space. That is incorrect. There's gravity in space. This has to do, though, with how much gravitational force there is on different planets, which has to do with how much you weigh. Later on this week, you will learn about how far you could throw something, jump, etc. on different planets. So, moving forward, and I'll show you a picture with this. Give me a second. What is the force that governs all planetary movement in the solar system? Well, when we talk about gravity, it's going to be the sun. The sun has a gravitational pull on every planet in the solar system. All right? And then we'll kind of talk about, because I know many kids asked me last week, well, why don't those planets fall into it then? And we can talk about that in a moment. But you'll want to make sure you do fill in this bottom section then and push pause and fill it in. Now, moving on to this last component. It's not on your notes, but you could add it. If you wanted to copy this down, even like as a note down here, it'd be really important to do that. Alrighty. Excuse me. How does the distance between two objects affect the force of gravity? Well, the closer the two objects, the more gravitational force they have. So for an example, the moon has a much larger impact on our tides, like water, than the sun does, because it's closer to us than the sun. For example, like Mercury has a larger gravitational force, like the sun has a greater pull on Mercury because it's closer to it, okay? So let me draw this picture. Kind of have a little room here, so kind of go with it. Let's go with this color. All right, so if this is our sun, and we'll make it like nice and pretty here. Okay, so if that's the sun, I'm just going to go ahead and do every planet then around it. Like if this is Mercury, Venus, Earth, Mars. Those are 4 inner planets, and then the 4 outer ones, Jupiter, Saturn, Uranus, and Neptune. All right, now I'm going to go ahead and draw their path. So for an example, the sun is the piece of body that governs everything in the solar system. Excuse me. So to explain this, the sun is going to have a gravitational pull on Mercury. So the reason why Mercury is technically, yes, falling into the sun. It is falling into the sun because the sun has a big gravitational pull on Mercury. So it's pulling in it. However, Mercury stays where it is in its path and it goes around the sun like this because of its velocity and inertia. So it has a certain speed, and then inertia, and then velocity is like a change in speed, hence the reason it's changing position and speed, and it's going around. So it's moving around. So it's kind of in like canceling out that force that the sun is pulling in on it, and it's kind of giving it a different type of force that evens everything out and kind of makes it stay put, and it just travels around the sun. So this is the same thing like on planet Earth. We are actually getting pulled into the sun, but the reason why the Earth is not just going into the sun is because, oops, sorry, that was a really bad circle, because of velocity and inertia, right? And that same process is because of the same thing. Now, these planets are in different positions. Like Neptune is way out here, and it goes around the sun, and it takes a longer time. It's slower. It takes a way longer time than Mercury, right? Mercury's only like 88 Earth years, or 88 days on Earth, and the sun, or the Earth, is 365 days, and Mercury takes 88 days. So Mercury's like whipping around the sun, and Neptune is like way out here taking its time. Well, just to let you know about that is the fact that the speed and the different gravitational forces. Well, the sun is pulling on Mercury a lot stronger than it is on Neptune. So that's a different force, all right? But it's canceling out that force because it's movement, it's velocity and inertia, all right? So we're going to just kind of pause for a moment because this will be the last part of the video. But you guys got to remember that there's different gravities on the different planets. It has like different gravitational constants. And because of that constant, just like that basic gravity it has, corresponds to how much we weigh on the different planets. But remember, our mass will not change. Okay, we know this from the first semester. So our mass doesn't change, but our gravity, the gravity is going to pull, like the force that pulls us down to that planet, it's going to affect our weight, and therefore that will change. Okay, now remember, the bigger the planet is, technically has to do with how much gravity that planet has. So the bigger the planet, the more mass that planet has, hence it's going to have more gravity. So technically, you'll probably weigh more on Jupiter, and you'll weigh less, like you'll weigh way more on Jupiter than you would on the moon, because the moon doesn't have that much gravity, but Jupiter does. Okay, so keep that in mind. The more mass a planet has will affect how much gravity it has. Okay. So we're going to move into this video. I'm not playing the whole thing, just a couple minutes of it. And it's a lady. She's just going to talk about the planets and kind of give you a visual aid with what I just talked about.
Has 8 planets. Can you name them all? Plus, there's a ton of moons and asteroids. You can learn more about the solar system in the astronomy series that we have on this website. But how does Earth stay in orbit? Let's first define what an orbit is. An orbit is the path an object takes to revolve or go around another object with mass due to gravity. But what does the gravity have to do with it? Well, remember this equation for the force of gravity between 2 objects that are not touching? There's an attraction between the sun and the earth that is trying to pull them together. If there were no gravity, the earth would just fly right on by the sun. There would be nothing to attract the earth towards the sun and keep it in orbit. But if there is a force pulling the sun and the earth towards each other, why doesn't the earth just crash into the sun? The earth has a velocity that is moving perpendicular to the sun. But as the earth passes by the sun, the earth feels the gravitational attraction and is pulled towards the sun. It is the combination of the Earth's perpendicular velocity and the gravitational force towards the sun that keeps the Earth in orbit. But what factors would make the Earth crash into the sun? If we made the force of gravity between the Earth and the sun larger, the Earth would crash into the sun. But what would we have to change to make the force of gravity larger? We would have to give the sun or the earth more mass. And lucky for us, mass cannot be created or destroyed. So we never have to worry about the earth crashing into the sun. Now we're going to play a game to explore all the possibilities of orbit with different masses. Let's play. Here we are in the Gravity and Orbits lab. We're going to do the example of the sun and the earth together, but you can do any of these when you play. Include the moon, just do the earth and the moon, or even try earth and a satellite. But we'll stick with this one for now. So what you can do here is you can change the mass of our sun, so we can either make it smaller or make it way bigger. This is what it is in real time right now, or we can change planet Earth's mass. We can make it smaller than it really is, what it actually is, or we can increase the mass. So another fun thing to do is we can turn on our gravity force arrows so we can see from the center of the Earth to the center of the sun, there is a gravitational attraction of both of these objects with mass. What do you think will happen to those force arrows if I increase the mass of the sun? That's right, they're going to get bigger. So this is just following the law of universal gravitation. And if I change Earth's mass, let's say I'm going to make Earth's mass less. Those force arrows get smaller. So let's just go to what we really see in our universe today. So I'm making the sun and the earth have the masses that they have. So this is the actual gravitational force that they have. And let's say, let's turn on the velocity arrow so you can see how it's always perpendicular to the orbit. And we're going to run the simulation. So now you can see these force arrows keeps Earth attracted to the sun, maintains that orbit shape, while this velocity is always trying to pull the Earth perpendicular away from the sun. So that's what our universe actually looks like. But let's see what happens now. I'm going to increase Earth's mass. What do you think will happen with this increased force between them? We can turn on our path to help us see. And if I increase it even more, you'll see those force arrows got even bigger now. They're passing each other. And what do you think is happening to my orbit? It looks like it's getting smaller. So orbit would get closer together. What would happen if I increased the sun's mass? Those force arrows are so big.
Now, what she's kind of explaining here is that what I told you guys about the fact that Mercury, there's a bigger force on the sun and Mercury, and that planet in turn is resisting that pull on the sun, and it's moving fast, okay, around the sun. Then Neptune, for example, way out there, our last planet, there's less of a pull from the sun, so therefore it's going slower, okay? So just remember, mass will not change. Yeah.
Looks catastrophic. Pretty cool, huh?
So in general, that just gives you an idea about gravity in our solar system, all right? There's going to be more on this, so yeah, but that's the first video.